All right, so we are going to move on to a few more ideas with this section. Continuity, being able to tell whether it's continuous, being able to state where a function is increasing or decreasing, um, boundedness, which is bounded above, below, or bounded, and then local and absolute extrema, which those really you want to think of as max and mins. So first of all, to think about continuity. A function is continuous at a point if the graph does not come apart at that point. I mean, that's the easiest way I can sort of say it in people terms. Is there a hole? Is there an asymptote? Is there just a break? If there is, it's not continuous. If it doesn't come apart, then it's continuous. So you look at these examples. This has no, I could draw that thing never lifting up my pencil. That is continuous for any x. Now, if you look at the second one, which is a removable discontinuity, there is a break, but it's sort of like this is up there instead of in the graph. It's not continuous at A. Now it's continuous at all other places. If that sort of is a point like that, it is called removable discontinuity. Third one, same thing. This is not continuous at A. Now it's the same exact thing. There's no point at A, but it's a removable discontinuity. Only place where it's not continuous is A. The next picture, jump discontinuity. That is not continuous at A because why is it called a jump? It jumps from here to there and then the graph continues. But if I said, is that graph continuous as a whole? No. Infinite discontinuity is really when you have an asymptote. This would be a vertical asymptote at A where it is not continuous. But big idea too, if something's continuous on a whole graph, you can draw it without ever lifting up your pencil. Next idea, increasing and decreasing. So the concept of it, graphically, the thing you always want to think is you are moving left to right. Okay, always. Left to right, that thing is increasing. Left to right, that is decreasing. If I look at the next one, that is constant, doesn't change. So you look at this last one, it's decreasing from negative infinity to negative 2. It's constant from negative 2 to 2. It's increasing 2 to infinity. The thing that we should know and get the idea of is when we answer, these are x's. I'm looking left to right. X is left to right. So that's how I answer. So you visually determine if a function is increasing, decreasing, or constant. It's increasing if a positive change in x, which a positive change in x is left to right, results in a positive change in f of x, which really means it's going up. It's increasing if from left to right it's going up. It's decreasing if a positive change in x, which is left to right, results in a negative change in y, which would mean it's going down. And it's constant if a positive change in x, which is left to right again, results in a zero change. It stayed the same. So that's the mathematical definition, but just think, going left to right, is it going up? Is it going down? Is it staying the same? How to answer. Be sure to answer as you move left to right. They are intervals of x's. So you put the x in terms of where the y is going. Increasing would be x intervals where the graph is going up. Decreasing, x values, intervals where the graph is going down. So really the thing that most people start to mess up with this stuff is how they answer it. You have to be very careful with how you answer. So if I said tell the intervals where the function is increasing and decreasing. Now you will be using a calculator or Desmos. So you put in x plus 2 squared. I know what this thing looks like. So I get this picture. Okay. I do need to know the maxes and the mins, which really that's where a lot of this comes together at the end. But you would want to find this point, negative 2, 0. So now you think, go left to right. You're always going to start with negative infinity because that's what's to the left. As you look left to right, your graph is going down. Don't look at the fact that there's an arrow pointing up. Left to right, my graph is going down. So it's decreasing from negative infinity to negative 2. I always use parentheses for these because at that point you can't really say it's equal to it. You're going to use it in both. So then what happens after that is it goes up. So it's increasing from negative 2 to infinity. But you do want to know you put them in your calculator. So with this one, which I'll just show this one, or Desmos. Just be careful with Desmos because you want to make sure you put them in there correctly with parentheses. So clear these out. I put in x squared divided by the quantity x squared minus 1. I graph it. Here's my picture. So when I look at that picture, I have to think left to right. And you also think about domain because you should know these asymptotes are at 1 because the bottom can't equal 0. So left to right, what's my graph doing to start? It's going up. So it's increasing from negative infinity to negative 1. Now then you have an asymptote. So then what happens there is it's increasing again from negative 1, and you would find that point which is 0, 0 to 0. Then it had a max, so now it's decreasing. So it's decreasing from 0 to the next asymptote, which is 1. And then right after that asymptote, which is right past 1, it's decreasing again to infinity. So you just have to make sure asymptotes you have to take into account in your answer. Boundedness. So the idea of boundedness is really, do you have an absolute bottom or an absolute top? So nothing is ever below it, nothing is ever above it, or is it between two things? So if you want to, like, the book does a mathematical explanation, but I think a lot of people, they struggle with this. This is unbounded. Now, what would I say? There is no max, there is no min. It's going up forever and ever, down forever and ever. This second one, this is bounded below. It has a point that it never goes below. You could also say I could draw an imaginary line and it never goes below that line. The line that it's bounded by is below. The graph is above that line. If I look at this one, just sort of completely backwards, it has an absolute max. So its graph is below, but where is the line that's bounding it? Above. So it is bounded above. This graph has an absolute max and an absolute min. I could also say it's between those two lines. It never has a higher y or a lower y. What we say with that, that is bounded. So if it's bounded above and below, it is bounded. With that, just, put the graphs in your calculator, look at the picture, make a statement. This is really where the mathematical definition is in the book. And really, it's bounded below if there's never anything below a given y. It's bounded above if there's never anything above a given y. Well, it has a min. The second one, it has a max. Absolute. So that's really the next thing. This is just to do one. If I say identify if it's bounded above, bounded below, or bounded, or if it's not bounded, you put this in your calculator. Well, 3x squared minus 4 looks like that. That has an absolute min. Everything is above it. But where is the min? It's at the bottom. So it is bounded below. The graph is above, but it's bounded by a y that's at the bottom. So bounded below. So last thing, local and absolute extrema. Peaks and valleys, where it changes from going up to going down, or vice versa. Okay, this is, we did this last year. Local, you could have lots of them. Absolute would be the highest point or the lowest point. You always list them all. I don't really ask you for which one's absolute, which one's local. So, you think of this just in general. This is a general little picture. Extrema is max and min. The second thing is, how do you say it? Y values occurring at X values. You know, defined it as it changes from going up to going down or vice versa. You know, that was going up, now it's going down. That is a max. Here, it changed from going down to going up. That's a min. Here, that's a max. Here, that's a min. Now, on this graph, those are all local mins and maxes because you have an arrow that goes forever and ever up, forever and ever down. How do you answer, which we did this last year? A max of 7 or y equals 7 at x equals 2. The min or the max is the y value. Where it occurs is the x. You do not give me ordered pairs. Desmos gives ordered pairs. Graphing Calculator gives us ordered pairs. You answer a y value occurring at an x value. And you tell me whether it's a max or a min. So with that, again, there's a book definition, but this sort of gives you an idea of how you set it. You know, you have a picture like this, and you put it in your calculator, and this comes out negative 2.56, negative 10.75. You don't tell me you have a min of that. You have a min of negative 10.75 at x equals negative 2.56. Now, this idea, relative, relative, absolute, I'm not going to ask you that. I just want min, max. I mean, but you do see the idea. This is relative. This is relative because the arrows are going up forever and ever. But this is absolute. Now, what does that also help you with? If you have an absolute min or a max, your function is bounded above or below. If you don't have an absolute, it's not bounded, so unbounded. So again, with that, put it in your calculator, find your maxes and mins, and just state them the way it was stated. So hopefully that helps, and we will see you the next class.